Hi, we're going to talk about project scheduling. And so the objective here is going to be about this is the overview objective project planning, controlling. We'll talk about uh, techniques for project scheduling. We'll talk about the PERT method, program evaluation review technique. That's what it stands for. We'll also talk about CPM method, and we'll talk about cost considerations using the CPM method. There's an attachment for you on uh, expected values of dependent variables. So start with the definition. So what's a project network or project scheduling? So a project is a collection of tasks or activities that must be completed. That's basically what it is. Generally, we want to complete all the tasks in a minimum amount of time or at minimal cost. So we have two objectives, either minimal amount of time or minimal cost. So project scheduling uh, is used for evaluating a schedule for research and development programs, construction projects, new product launch, preparation of bids and proposals, maintenance and planning, computer installations, political campaigns, event planning, production of motion pictures, etc., and so on. So there's many problems that would fit into this project scheduling. So these ones in these situations, the objectives would be the following. So we want to plan and control a project efficiently to determine the minimal expected completion time. We want to determine which activities are critical. A critical means if you delay an activity, that will delay the whole project. We want to find out the earliest and latest time each activity can be started and completed. Because remember, these activities, some of them cannot be started until other activities are completed. So we have to plan carefully. We want to find that amount of slack time for each activity. So how much each activity can be delayed without affecting the completion of the project. Which of the completion alternatives is most cost effective? So now involving cost in the project. Which activities should we spend more resources on? Because if we really get them in a short amount of time, that would minimize or shorten the amount of time we need to complete the project. Whether or not a project is on schedule or on budget. So we want to find out if we can complete the project on schedule and on budget. We're going to schedule the activities in such a way that offer consistent level of resources while completing the project in minimal time. We want schedule activities that completes the project in minimum time given the limits on availability of one or more of the resources. So we have two methods, two approaches to undertake such projects, both developed in the 50s, and one of them is called PERT, Program Evaluation and Review Technique, and this one treats completion time of the activities as random variables. So it's random. So now we have a source of randomness, which is the completion time of each activity, and each one will have a specific probability distribution associated with it. And the other method is called the CPM method, or the critical path method, and this one assumes completion of an activity is dependent on how much money we can spend on it. So spending more money, you finish the activity sooner, so you're going to balance the duration of the activity with the amount you want to spend on it. Both PERT and CPM use network models. So to build a network, we need the following. So we need to define the activities of the project. We need to identify the specific precedence relationship between those activities. So what activities must be completed before another one starts. We're going to build the project using a technique called activity on node network, okay? Which means each activity will be a node and the relationships will be represented by arrows. We'll show you an example of that shortly. There are other methods like activity on arcs, but we are not going to do that. So this has become very, very popular and it's much easier to work with. That the other method has been really rarely used. So how do we identify the activities? So we have to be careful when we identify these activities because some of them may be easy, others may be more fuzzy. So we have to always find the right level of detail. We don't want our activities to be very detailed, so we have a very large number of activities to work with, and we don't want them to be very general so that we cannot control them. We can't estimate their time of completion and the resources they take to be completed. So we have to balance both cases. The Gantt chart is a popular technique that used to display activities. So I'm going to show you one right now just to give you an idea of how Gantt charts works. They are named after Henry Gantt. They were developed in early 1900s, and so they measure the time on horizontal axis, and each activity is listed on the vertical axis and the bar is drawn corresponding to its expected completion time. So if you look at this is an activity, this is a Gantt chart where I have these activities, say like developing a new product would require market research, define specifications, overall architecture, project planning, detailed design, software development, test plan, testing and quality assurance, user documentation. You can see here I start my activity market research early on. The second activity cannot be started until the first one is completed. The third activity cannot be started until this one is completed. Project planning can be started before this activity is completed, but cannot be started before this is completed. And you can see here this activity cannot be started unless these activities are completed, but it can start without any of these two being completed, and so on. So this is an idea of these project networks, and here we identify some of these milestones in the project progress. Okay, so it helps us if I'm at this point in time, I can tell which activities are completed, which activities I'm working on, and which activities are left. And this distance here gives me sometimes like this activity, this can be delayed without delaying this activity, and so on. We'll talk about this later, but this is the idea of the Gantt chart. It's a visual display of activities and their durations. Okay? To go back, summarize what we did. So what we want from a project scheduling is to identify earliest or latest start times of each activity and the earliest latest finish times of each activity, and also for the whole overall projects. We want to be able to identify slack time, so how much an activity can be delayed without delaying the project. So if an activity cannot be delayed without delaying the project, which means if I delay an activity, the whole project will be delayed, we call that a critical activity. So we have to pay special attention for those activities because they can cause problems if they are delayed. So I want to find out the total slack and the free slacks, which we'll talk about later. Talk about how do we estimate activity completion times and its effect on resource shifting, the impact, random variation. So the duration of activities is the source of randomness. They are random. How would that their impact on the estimated activity and project completion time? We're also going to talk about cost analysis, costs under normal conditions, cost under fully crashed conditions. Fully crashed means if we have a lot of money and we spend it on all as much as we could on each of the activities, what's the earliest completion time? This is a fully crashed project network, is the method used during World War II to develop the atomic bomb, because and so there were multiple projects going on with all the resources needed to finish the atomic bomb in minimal time. So the minimal costs associated with meeting a project target completion time. Also, we want to find out if we have a deadline to finish a project, what's the least amount of money we can spend to complete the project in that time. So now we're going to focus on the PERT approach, program evaluation review technique. We're going to talk about, remember, we have activities. We talked about these. Activities are one of many time resource consuming elemental tasks in the project. This is one of the basics, which is the most detailed subdivision of the total project. So activities are represented by nodes. We're going to label them by circles or squares. Activities consume time and resources. Factors to be considered in determining an appropriate level of detail for activities is ability to identify and predict critical and near critical activities. Difficulty anticipated in controlling predicted critical and near critical activities. We talk about amount of time available for scheduled completion of project relative to the amount of time anticipated to complete the project. Availability of cost of information, degree of delegation of responsibility for specific segments of the project. Arcs used to show precedence relationship among activities. They consume neither time nor resources, which just indicate an activity cannot be started until some other activities have been completed. So if we put those activities or the circles and the arrows together, we have an arrangement. We end up with a network diagram, which is an orderly arrangement of nodes and arcs to represent those relationships, the precedence relationships of all these activities, their durations to complete the project. So if we have activities on parallel path, that means they can take place concurrently. So let's just make all of this talk concrete and talk about a specific example. So here I have a small project composed of 6 activities that have the following precedence relationship and duration times. At this point, I'm not going to introduce randomness into the project. We'll do that later. So I'm going to call those activities A, B, C, D, E, and F. Activity A starts at time 0 when I start the project. Activity B cannot be started until A is completed. So that's the preceding activity. C cannot be completed until A is completed, but doesn't require B to be completed. Activity D requires C to be completed. E requires B to be completed, and F requires D and E to be completed. And the durations of these activities are it can be in days, 3, 4, 1, 3, 7, 4, 9, and 1. And so if we put these things together, you should be able to get this diagram. So that's activity A, its duration. B cannot be started until A starts, which takes 3 days. C only requires A, so it doesn't have to, there's no arrow from B to C. If there's an arrow here, that means C cannot be started until A and B are completed, but we don't need that. D requires only C. E only requires B to be completed, and F requires both E and D to be completed. Okay, so this is my network diagram, and you notice there are some other spaces here. So that's the, I want to give you the legend for that, because we're gonna put here the earliest start time, earliest finish time, latest start time, and latest finish time, and we should be able to compute that from the information provided in this network. Right, so that's our example. The definitions, so earliest start time is the earliest time at which an activity can start, assuming all predecessors have been completed. Earliest finish time, the earliest time at which an activity can be finished. Latest start, the latest time at which an activity can start so as not to delay the completion of the project. So how much what's the latest start time of an activity so that the entire project is not delayed. Latest finish is the latest time by which an activity has to be finished so as not to delay the completion time of the project. Okay. Labeling a network with earliest, latest, finish times requires a forward pass and a backward pass using the estimated activity times. So when we go forward, we can compute, I want to show you that on the graph, the earliest start times, and then begin with the starting event, and work to the end we calculate earliest start, earliest finish, and the earliest start time is the maximum of all finish times of all immediate predecessors. Mathematically, we can write that as earliest start time for activity I. If you take the earliest start time for activity K, add the duration, take the maximum, where K represents all activities that are immediately precede activity I. So K for all those ones that are immediately precede activity K, which means they have arrows that lead to I. Right? Earliest finish time, these are the earliest estimated finish time for activity I, and the rule for them is just you take the earliest start time, you add the duration, and you get the earliest finish time. In the backward pass, first we compute the latest finish time, and that's the latest estimated finish time for activity I without delaying overall completion of the project. So we begin with the last event and work backwards to the beginning, calculating latest finish time and latest start time. Okay, so the latest finish rule is this: we take L as latest start of all immediate following activities, or mathematically, so we take for there's an activity I, and pick all the activities K that are immediate successors of I, that I have arrows lead to them, and take their latest finish time minus the duration, and I pick the smallest of these, and that would be my latest finish time for activity I. The latest start time for activity I is basically latest start is the latest finish minus the duration of the activity. Okay. So now doing all the calculations, I ended up with this network where this would be my earliest start, earliest finish, latest start, latest finish. So how do we, and this is a key here to help you keep track with that if you forget. So let me go and do these calculations on the graph for you so you can see how it works. So my earliest start time for activity A is 0, and I only at this point only have the durations of these activities. So now I found out the earliest start time in this space here. So the earliest start time of activity B is 0 plus 1, that gives me 1 here. The earliest start time of activity C is, go back to this one here, 0 plus 1 gives me 1. D now, the earliest start time of this activity is this plus this gives me 8. And the earliest start time of this activity is this plus this gives me 4. And the earliest start time for this activity is 8 plus 4, 12, but I have 2 activities lead to it, so I need also to compute 4 plus 9, 13, and pick the maximum. The maximum is 13. Okay, so that gives me all the earliest start time. Now I want to fill in those pieces here. So these are the earliest finish time. So 0 plus 1 is 1, 1 plus 7 is 8, 1 plus 3 is 4, 8 plus 4 is 12, 9 plus 4 is 13, 13 plus 1 is 14. So that's my earliest finish time for the last activity, which should be the same. So that's my as latest finish time for the last activity. So that one goes down here because that's the completion of the project. Earliest finish, earliest start are the same. And now I do my backward pass to compute the last finish time, which means those numbers here. Let me show you how we do that. So from this one here, I want to go back to what this minus this. Oh, this 14 minus 1 is 13. That would be my latest finish for E. I go to D here. There's an arrow here, so I'm going to do this. 14 minus 1 would be 13, latest finish. Now I go here. This is the one that comes after it. So 13 minus 4 is 9. For this one, I go to this. 13 minus 9 is 4. And now for this, I have 2. So I have to do 9 minus 7 is 2. 4 minus 3 is 1. And now I pick the minimum. So 2 and 1, the minimum is 1. And now I want to get the latest start. Latest start would be 14 minus 1 is 13. 13 minus 9 is 4. 13 minus 9 is 4. 9 minus 7 is 2. 4 minus 3 is 1. 1 minus 1 is 0. Okay, and so that gives me the all these activities here. And the textbook actually uses a similar notation, but it's more rectangular. So they use activity I here. Duration is here, earliest start, earliest finish, latest start, and latest finish. Okay, so I want to continue with this in a second video.